Integration in kinematics of linear motion. So previously we have learned how to get the velocity and acceleration function from the displacement function by differentiate the function, and you will get the velocity and acceleration function. But if the acceleration function is given, how can we determine the velocity function and displacement function? So when we have the acceleration function, the velocity function can be determined by integrating the acceleration function with respect to time. If we have the velocity function, the displacement function can be obtained by integrating the velocity function with respect to time. When the acceleration function given, the displacement function can be obtained by performing two consecutive integrations, like this. Let's do a recall. Your chapter 3 integration, indefinite integral. So if you integrate k dx, you will get kx plus c. Integrate x power of n dx, you will get x n plus 1 over n plus 1 plus c, a constant. So integrate ax power of n dx, you will get ax n plus 1 over n plus 1 plus c. Let's do example 12 in your textbook. A particle moves along a straight line and passes through a fixed point O with a velocity of 12 meters per second. The acceleration a at t second after passing through O is given by a 4 minus 2t. So like before, we have to find the displacement, velocity and acceleration function. Now we have to move upward and perform integration. To find the velocity function, you have to integrate the acceleration function, and to find the displacement function, you have to integrate velocity function. Given that the acceleration function is 4 minus 2t, and from the equation we know that the particle passes through a fixed point O with a velocity of 12 meters per second. So the velocity we get by integrate the acceleration function is 4t minus 2t square over 2 plus c. And how we want to find the constant? So from the information above, when t is equal to 0, the velocity is equal to 12. So substitute into the velocity function. You will get the value of c is equal to 12. Then write the velocity function as 4t minus t square plus 12. Take note the acceleration function and velocity function we get. Now to find the displacement function, we have to integrate the velocity function, and you will get 4t square over 2 minus t cubed over 3 plus 12t plus c. From the question, we know that the particle passes through a fixed point of O. So we know that t is equal to 0, s is equal to 0, and substitute into the displacement function to find the constant. So the value of c is equal to 0. Hence the displacement function is 2t square minus 1 over 3 t cubed plus 12t. So this is the displacement function. Now we are going to answer the question. Okay, determine the instantaneous displacement of particle from O when t is equal to 3. So substitute t is equal to 3 into the displacement function. 2 3 square minus 1 over 3, 3 cube plus 12 3, and you will get the displacement is 45 meter. Next, A2, determine the instantaneous displacement when the particle is at rest. When the particle is at rest, v is equal to 0, so find the value of t. So look at the velocity function. For t minus t square plus 12 is equal to 0. Then we write it in general form. Negative t square plus 4t plus 12 is equal to 0. T square minus 4t minus 12 is equal to 0. Then we factorize it. T minus 6. T plus 2 is equal to 0. T is equal to 6. T is equal to negative 2. But always remember that time will always be positive, so we choose t is equal to 6 seconds. So the displacement for t is equal to 6 is, we look at the displacement function and substitute t is equal to 6. And you will get the displacement is 72 meter. B. Next, find the distance in meter traveled by a particle in 7th second. Mean distance traveled by the particle from t6 to t7 means that you can use the formula S7 minus S6. So first find the S7 first. Substitute t is equal to 7 into the displacement function. The answer for S7 is 67 2/3. For S6, you have calculated it in A2, which is S6 is equal to 72 meter. So distance traveled by a particle in the 7th second is equal to modulus S7 minus S6 modulus 67 2/3 minus 72, and you will get 4 1/3 meter. For second question, a particle moves along a straight line with acceleration of a is given by a is equal to 6t minus 8, where t is time in seconds after passing through a fixed point. Find the displacement of the particle at time t. So, like usual, we find the SVA function. A is given 6t minus 8. So we integrate it to find the velocity function. 6t square over 2 minus 8t plus c. So t is equal to 0. V is equal to 0. Substitute into the velocity function to find the value of constant. Hence, we get the value of c is equal to 0. So the velocity function is 3t square minus 8t. Now find the displacement function by integrate the velocity function. 3t cube over 3 minus 8t square over 2 plus c. So here we know that t is equal to 0 and s is equal to 0. So substitute into the displacement function to find the value of c. hence we get c is equal to 0. So the displacement function is t cubed minus 4t squared. We have find the displacement, velocity and acceleration function. Let's answer the question. So A, the displacement of the particle at time t. So the answer is S is equal to t cubed minus 4t squared. B, total distance traveled in the first 5 seconds, meaning that the questions want the total distance traveled by the particle from t0 to t5. So we have to consider initial, rest and end. For initial is t is equal to 0, so substitute t is equal to 0 in the displacement function. So S is equal to 0. For rest, we know the particle is at rest when v is equal to 0. So find the value of t first. Look at the velocity function. 3t squared minus 8t is equal to 0. Then we factorize it. T bracket 3t minus 8 is equal to 0. So we get t is equal to 0 and t is equal to 8 over 3. Substitute t is equal to 8 over 3 into the displacement function. S is equal to negative 9 13 over 27. Therefore, the particle is located 9 13 over 27 meter from the fixed point O when t is equal to 8 over 3. So lastly, t is equal to 5. So substitute t is equal to 5 into the displacement function and you will get S is equal to 25 meter. Hence, the instantaneous displacement when t is equal to 5 is 25 meter. Now we draw a number line to illustrate the movement of a particle. So this is the fixed point. Negative 9 13 over 27. This one is 25 meter. T is equal to 0, S equal to 0. At t is equal to 0, the particle is at the fixed point O. At t is equal to 8 over 3 seconds, the particle is located 9 13 over 27 meter from the fixed point O before changing its direction. At t equal to 5, particle moves to the right 25 meter from the fixed point. So total distance traveled in the first 5 seconds, we look at the number line. 9 13 over 27 plus 9 13 over 27 plus 25 and the answer is 43.26 over 27 meter.